Hello friends, today I am here with the next portion of motion of earth, and I already taught about rotation and revolution. I already taught about this, and I told that effect of rotation is what? Day and night. Effect of rotation is what? Day and night. Because of rotation we can observe day or night, and I told because of revolution we can see what? Formation of season. Formation of what? Season. Okay, but alone revolution cannot be responsible for the formation of season. That means revolution cannot only the factor for the formation of season. There is one more factors which is responsible for the formation of season, that is what? Inclination of earth. Inclination of earth. Okay, so revolution as well as inclination of earth, these are the two factors which are responsible for formation of season. Besides this, we can see what in the summer days, these days are summer in India, and summer days are longer and winter days in India are what? Shorter. This is said to be what? Variation of day and night, or longer day, smaller night, or smaller day, longer night. These are said to be what? Variation of day or night. The variation of day and night mainly caused because of what? Inclination of earth. So because of inclination of earth, what is happening? Formation of season are taking place. Also revolution is also responsible for formation of season. These two factors, revolution as well as inclination of earth, are responsible for formation of season, and the variation of day and night is responsible for inclination of earth. That means because of inclination of earth, the variation of day and night occurs. Now we have to know what is inclination of earth. We have to know what is inclination of earth. What is inclination of earth? What is inclination of earth? Actually what happens, if this is the earth, and this is what? Axis. This axis is what? Vertical axis. Earth is inclined about 23.5 from the 23.5 degrees from the vertical axis, or earth is inclined at 66.5 degree from the horizontal axis. You can say earth is inclined at 23.5 degree from this vertical axis, or you can say earth is inclined at 66.5 degree from the horizontal axis. This inclination, or this is what? Tilting, is called what? Is called inclination of earth. That means earth is tilted at 23.5 from the vertical axis, or earth is tilted at 66.5 degree from the horizontal axis. This is what? Inclination of earth. Now we have to know two concepts before proceed the lecture. That two concepts are what? Number one is what? Axis. We have to proceed. We have to know what about axis, and what? Number two, line of illumination. Okay, line of illumination. What is axis? I already told in the first class, axis is nothing but it is an imaginary line. It is an imaginary line which connects what? 90 degree north to 90 degree south pole. If an imaginary line which connects 90 degree north to 90 degree south is called what? Axis. Now let us suppose the 90 degree north is shifted to here and 90 degree south is shifted to here. Can it be the axis? Yes, will also be what? Axis, because it is connecting 90 degree north to 90 degree south. Suppose 90 degree north is connected to here, okay, and 90 degree south is connected to here. Can it be an axis? Yes, it is also an axis because it is connecting 90 degree north to 90 degree what? South. Any imaginary line which connects what? 90 degree north pole to the 90 degree south pole of the earth is said to be what? Axis. Now what is line of illumination? So to know line of illumination, what we have to learn, in order to know line of illumination, next our topic is what? Line of illumination. Okay, so suppose this is the earth, okay, and this is the axis. Suppose this is the axis, this is the sun, okay. So this is 90 degree north, this is 90 degree south, okay. So sunlight will fall here. The sunlight will fall in this region. Okay. So this region will become what? Day. And this, in this region, sunlight will not fall, because of which it occurs what? It occurs what? Night. So this line is separating what? This line is what? Separating day and night. The line which separates day and night is called what? Line of illumination. The line which separates day and night is called what? Line of illumination. Okay. Now, before moving further in the lecture, I would like to study 2 case studies. That means now I will do 2 case studies. Case 1. Let us suppose earth is not inclined. Earth is not inclined. Or inclination is 0, or inclination is equal to what? 0. So first of all, I will take the case of when earth is not inclined or inclination is 0. Second case, if inclination is not 0. If inclination is not 0 means if earth is inclined. Okay, first case inclination is 0, second case inclination is not 0, earth is what? Inclined. So first I will do what? If earth is what? Inclined. Sorry, if earth is not inclined. Okay, if earth is what? Not inclined. First case I will study what? If earth is not inclined. Let us suppose this is the sun, okay, and this is what? Earth. Okay, this is the axis. Since earth is not inclined, so axis will be this only. Okay, earth is not inclined, I am assuming. So what happens? This is what? Equator. Okay, equator is also called what? Largest latitude. Okay, and this is what? 23.5 degree north, and this is what? 66.5 degree north and 90 degree north. Similarly, this is what? 23.5 south, and this is what? 66.5 south, and this is what? Sorry, this is 90 degree south. Okay, so sunlight will fall in this region. Okay, sunlight will fall in this region. Okay, and here what happens? This region will become day. This region will become day. This region will become day. This region will become what? Night. Okay, so what happens at equator? This is the day, equal nights, equal day, equal nights, equal day, equal nights, equal day, equal nights, equal day, equal nights. Okay, so if earth would not be inclined, or if inclination would have been 0, then what we are observing? We are observing what? This is northern hemisphere, this is what? Southern hemisphere. Okay, above equator is northern hemisphere, below equator is what? Southern hemisphere. So we are observing what? First case we are observing what? First case is what? Axis is equal to what? Line of illumination. If inclination would have been 0, first case what we are observing? Axis is equal to what? Line of illumination. Second case what? Day is equal to night in everywhere. Day is equal to night in everywhere. So if day is equal to night in everywhere, so season would have been what you can, and here northern hemisphere, if northern hemisphere is what? Summer, then southern hemisphere would have been also be what? Summer. If northern hemisphere would have been winter, then southern hemisphere would have also been what? Winter. Okay, because temperature is same in both the sphere, northern hemisphere and southern hemisphere. If inclination would have been what? 0. So these are the three things we can conclude. Number one, axis is equal to line of illumination, because this is a vertical axis, along with the this is also what? Line of illumination. Number two, everywhere day is equal to night. Number three, if northern hemisphere is summer, southern hemisphere is also summer. If northern hemisphere would have been winter, then it would have been also winter. So this is the first case. Number two, which actually this case is not possible, because we know the earth is what? Inclined. So this is just imagination. Number two case. Next we are moving what? Number two case. What is number two case? Number two case is what? If earth is what? Inclined. If earth is what? Inclined. So I will move next case. Next case is what? If earth would have been what? Inclined. What is next case? Next case is what? If earth would have been what? Inclined. If earth would have been what? Inclined. So if earth would have been inclined, so for that case, if earth is what? Case 2 is what? If earth is inclined. So let us suppose okay, this should have been what? Axis, but since earth is tilted, so it would not be axis, it would be what? Around. Okay, so this would have been what? 90 degree north, this is 90 degree south, because earth is what? Tilted from its vertical axis. I am taking this one, no, earth is tilted from the what? Vertical axis. Second case is that. Now if earth would have been tilted, which is in real case earth is already tilted, so when it was not tilted, this was what? Equator. Now since earth is tilted, therefore equator will also be in the same. Equator will also be what? Equator will be what? Like this. This will be what? Equator, 0 degree. Okay, largest latitude, 0 degree. Now this would be what? 23.5. It will be somewhere, okay, in north. This would be what? 23.5 south. Okay, I am not showing yet 66.5 because of course I will do this later portion of the class. So now I am showing only 23.5, 23.5 north and 23.5 south. If we move up, then again you will get 66.5. Okay, here also you will get 66.5, but I am not showing because already I will do in the later portion of the class. So I am not showing all these things. So this is what? Suppose sun. This is sun. So can anyone tell me in which portion sunlight will fall? Can anyone tell me in which portion sunlight will fall? In which portion sunlight will fall? Earlier sunlight was falling in this portion because what? Earth was not tilted. Now can anyone tell me in which portion of the earth will receive sunlight? Only the problem of the earth, na? Only earth is tilted, no? There is no problem from the sun. Sun will fall in the same region where earlier it was falling. So sun will fall, sunlight will fall from here to what? Here. Okay. And remember, in this case what is happening? First case is what? What you can observe? Axis is not equal to what? Line of illumination. Why? Because this is axis, line of illumination is this, because this this, because this portion will become what? Day. This portion will become night, and days are separating from night by this line, and this line is called line of illumination. So here axis is not equal to what? Line of illumination. Okay, first case, axis is not equal to line of illumination. Second case, in the equator, what happens? Equal day, equal night, largest day, smaller night, larger day, smaller night. Okay, smaller day, larger night, smaller day, larger night. So what we are observing is, at equator day is equal to night. At equator day always become equal to what? Night. Duration of day always become equal at night at equator. But if we move up, what we are observing, days are what? Days are, duration of days are increasing and duration of nights are decreasing. Here also duration of days are decreasing, nights are increasing. Days are decreasing, nights are increasing. So it's opposite. If we move up or move above the equator, what we are observing, duration of days are increasing, and if we move down, duration of days are what? Decreasing. Okay, so what we can number one point, we are observing that axis is not equal to line of illumination. Number two, at equator what? At equator day is always equal to what? Night. You remember, at equator day always become equal to what? Night. Number three, if we move up the equator, up the equator, what is happening? Days are increasing, duration of days are increasing, and night is what? Decreasing. But if we move down the equator, what you are observing? Days are decreasing and night are what? Increasing. Okay, and this is what? This is northern hemisphere, this is what? Southern hemisphere. Okay, in this condition, what our assumption was, earth is inclined towards northern hemisphere. Sorry, I have not written here, towards northern hemisphere. Okay, northern hemisphere. Okay, my handwriting is not so good, but since I am telling, so what is the what? Case 2, if earth is inclined towards northern hemisphere. So earth is inclined towards what? Northern hemisphere. So earth is inclined towards northern hemisphere. Sorry, not earth is inclined towards northern hemisphere. Northern hemisphere is tilted towards sun. Sorry, it's okay. What I have to say? Northern hemisphere is what? Tilted towards sun. Okay, northern hemisphere is what? Tilting towards sun. Okay, so if northern hemisphere is tilting towards sun, southern hemisphere is moving away from the sun. Southern hemisphere is moving away from what? Sun. Okay, northern hemisphere is tilting towards sun, southern hemisphere is tilting against, so southern hemisphere is what? Moving away from what? Sun. So in this case, northern hemisphere will become what? Summer, and southern hemisphere will become what? Winter. In the reverse case, if southern hemisphere would have been tilted what? Towards sun, if southern hemisphere would have been tilted towards sun, then southern hemisphere would have become what? Summer, and northern hemisphere would have become what? Winter. But since we are taking northern hemisphere towards sun, so in northern hemisphere it is becoming what? Summer, southern hemisphere it is becoming what? Winter. Okay, so these two case studies will help in the further study of the class. Okay, now we will study in details about what? We'll study in details about, okay, about rotation and revolution in details. We'll study about rotation and revolution in what? Details. Okay, we'll study about rotation and revolution in what? Details. So now see, this is sun, this is what? Sun. Okay, let me draw a little bit away so that I can do here also something. This is what sun, this is sun, okay, and this is earth, okay, this is earth. Okay, this is earth. Earth is taking selfie here, earth is taking selfie here, earth is taking selfie here, and earth is taking selfie here, okay. This is the axis, this is the axis, but remember earth is taking selfie here on the date of 21st June. 21st June, earth is taking selfie here. On date 23rd September, 23rd September, earth is taking selfie here. On date 22 December, earth is taking selfie here. And on date 21st March, earth is taking selfie here, okay, okay. Now this is equator 0 degree, this is Tropic of Cancer, okay, this is Tropic of Cancer, this is Tropic of Cancer, okay. This is what Tropic of Cancer means 23.5 north, okay, and this is what, and this is what 66.5 north, 90 degree north, okay. I am drawing the diagram. It is not possible to draw it nicely because I am doing class now, not writing examination, okay. So this is what 23.5 south, and this is what 66.5 south, okay. This is equator 23.5 north, 66.5 north, 90 degree north, okay. 23.5 south, 66.5 south, 90 degree south, okay. Now this is equator, this is equator, okay, this is equator, or let us suppose this is equator, this is 23.5 north, this is 66.5 north, this is 90 degree north, this is what 23.5 south, this is what 66.5 south, this is 0 degree equator, okay. Similarly, same thing, I am not telling again and again, same thing, but 0 degree, 3.5, 66.5 north, 90 degree north, okay, 23.5 south, 66.5 south, 90 degree south, okay. So what you have, there are some points which you have to remember, okay. There are some points which you have to remember. On 21st June, sunlight falls perpendicularly on what? Tropic of Cancer, or 23.5 degree north. 23.5 degree north is called what? Tropic of Cancer. On 21st June, what happens? Sunlight directly falls on perpendicular to what? Tropic of Cancer here. On 23rd September, what is happening? Sunlight is directly falling what? Sunlight is directly falling on what? Sunlight is directly falling on what? Or perpendicularly falling on what? Equator. Remember, you have to remember. On 22 December, what is happening? Sunlight is falling perpendicularly on what? Tropic of Capricorn or 23.5 south. And on 21st March, sunlight is perpendicularly falling where? On perpendicularly is falling on what? Equator. Okay. So these are the things which you have to remember. First, on 21st June, sunlight is perpendicularly falling on what? Perpendicularly falling and slanting. I am showing you. Suppose, see here. Suppose this is the part. This is the earth surface. This is A, B, C. 3 points are here. This is sun. So sunlight is falling here. Means it is perpendicularly falling off sun only. Okay. This is said to be what? Sunlight is falling perpendicularly. And sunlight falling at B is said to be what? Perpendicular falling of sunlight. Sunlight falling at A and C is said to be slanting. Okay, slanting. S-L-A-N-T-I-N-G, slanting. So at B, sunlight is falling perpendicular. At A and C, sunlight is falling what? In a slanting ways. Okay. Now I think you are clear what is perpendicular falling of sunlight. So what is happening? On 21st June, sunlight is falling perpendicular to Tropic of Cancer or 23.5 north. On 23rd September, sunlight is falling perpendicular to what? Equator. On 22 December, sunlight is falling what? Perpendicularly to what? Tropic of Capricorn or 23.5 south. On 21st March, sunlight is falling perpendicular to what? Equator. These are the things you have to remember. And also you have to remember on 21st March, what is happening? 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 Can anyone say me? Can anyone say me on 21st March what is happening? Okay, think little bit. Give the video pause and what would have happened on 21st March? Can anyone tell me? In 21st March, what is happening? Axis is becoming equal to line of illumination. Similarly, on 23rd September, axis is becoming equal to what? Line of illumination. These are the things which you have to remember. Okay. And on 21st June, line of illumination is passing what? From 66.5 north to 66.5 south. Okay. These are the things which you have to remember. Okay. What you have to remember? On 21st June, line of illumination is passing from 66.5 north to 66.5 south. This is the line of illumination. Okay, and this is already exists. Okay. Similarly, on 22 December, line of illumination is passing from 66 degrees north to 66 degree what? South. Okay, this is the line of illumination. Line of illumination. So in this case, 21st March and 23rd September, axis is become equal to what? Line of illumination. But on 21st June, axis is not equal to what? Line of illumination. Here also axis is not equal to what? In this case, axis is not equal to what? Line of illumination. This you have to remember. Okay. Now let us move here. What? On 21st June. So what we are observing on 21st June? Can anyone say me? Can anyone say me what we can observe? What we are observing on 21st June? On 21st June, what is happening? See here. This is what? Line of illumination. Remember, this is what? Line of illumination. Okay. So it separates day from night. This region will become day, and this region will become what? Night. So on 21st June, what is happening? At equator, equal day, equal night. At 23.5, larger day, smaller night. At 66.5, what is happening? Here all the day, no night. Okay, so what we are observing on 21st June, and again if we move down, what is happening? Smaller day, that means at 23.5 south, smaller day, larger night. Okay, at 66.5 south, what is happening? No day, only night. Okay, so here what we are observing, or what we can summarize in 21st June, we can summarize that at equator, what is happening? You remember, at equator everywhere day become equal to what? Night. No need to worry. But if we move up above the equator, what we are observing? Day is what? Increasing. Day is increasing above equator. Okay, and at 66.5 north, what we are observing? Only day, or 24-hour day. Only day means what? 24-hour day, no night. Where? At 66.5 north, only day, no night. Okay, only day, no night. Similarly, if we move down the equator, what we are observing? Nights are what? Duration of nights are increasing, and at 66.5 north, what is happening? 66.5 south, what is happening? Only night, no day. Only night, no day. So here only night, no day at 66.5 south. So India falls under where? India falls under northern hemisphere. So at 23.5 north, this is said to be what? 23.5 north is said to be topic of Cancer. India falls under what? Northern hemisphere. And on 21st June, we can observe what? Longest day. Indian can observe what? Longest day on 21st June. Okay, this is called what? Summer solstice. This is said to be what? Summer solstice. Okay, so for northern hemisphere people, or for northern hemisphere of the earth, 21st June is said to be what? Summer solstice, because 21st June is a hotter day, summer day, and it is the longest day. That is why it is said to be what? Summer solstice. And 21st June, can anyone tell me, 21st June is said to be winter solstice in southern hemisphere? Why? You write this question, 21st June in the southern hemisphere is said to be what? Winter solstice. Why? Okay, so write in the comment section. Now here what we can conclude from this? What we can conclude? We can conclude that the days are increasing moving up the equator, days are decreasing moving down the equator, and if here northern hemisphere is what? Summer. Here northern hemisphere is what? Northern hemisphere is summer, and southern hemisphere is what? Winter. Northern hemisphere summer, southern hemisphere is what? Winter. Okay, and temperature of northern hemisphere will be more than that of what? Southern hemisphere. Okay, so these are the things which you have to remember. Okay, next, if I move to 22 December, okay, this 12 is together. Now I am moving to what? 22 December. Okay, now we are moving to what? 22 December. So what we can observe in 22 December? Can anyone say me? Can anyone say me what we can observe on what? 22 December. Can anyone say me? Very simple. On 22 December, what is happening? On 22 December, what is happening? Sunlight is perpendicularly falling on Tropic of Capricorn, 23.5 south. Okay, now we'll observe. At equator, what is happening? Equal day, equal night. Moving down the equator, 23.5, larger day, smaller night. At 66.5 south, what is happening? Only night. Okay, now at 23.5 north, smaller day, larger night. At 66.5 north, only night. is complete opposite to here. Okay, what we are observing here is the complete opposite to here, because here line of this line is what, this line is what, line of illumination. I already told this line is what, line of illumination. Okay, so line of illumination is not equal to what, axis in this case, and on 23.5 south sunlight is falling perpendicularly. At equator day is become equal to night everywhere, a day become equal to night at equator. Moving up we are observing smaller day, larger night, and at 66.5 what we are observing, the only night at 66.5 north. Similarly if we move down, what we are observing at 23.5, larger day, smaller night. At 66.5 south, what we can observe, we are observing completely day, completely opposite of this. Okay, if you are understanding this you will also, you will understand. At 66.5, complete what, complete day, no night. Okay, so what we can summarize from here, we can summarize is what, we can summarize that line of illumination is not equal to axis. On 23.5 south sunlight is falling perpendicularly at that means on 22 December sunlight is falling perpendicular to what, 23.5 south or Tropic of Cancer. On 22 December sunlight is falling perpendicular to what, 23.5 south, and days are decreasing on moving up the equator, and at 66.5 it only night, no days, and moving down the equator we are observing what, days are increasing. At 66.5 south, longest day. Okay, and this 22 December for the northern hemisphere, this for the northern hemisphere 22 December become what, winter solstice. For northern hemisphere, okay, for northern hemisphere 22 December is what, winter solstice. Okay, and this is the shortest day for the northern hemisphere and the longest day for the what, southern hemisphere. Okay, and for the southern hemisphere 22 December is said to be what, it is a summer solstice. Okay, 22 December for the southern hemisphere is said to be what, for the southern hemisphere it will be summer solstice. For the northern hemisphere 22 December is said to be what, winter solstice. Okay, now next we will move what, we'll move to what, 21st March and 23rd September. So here on 21st March axis become equal to line of illumination and sunlight perpendicularly falls on the equator. Okay, on 21st March as well as 23rd September. Okay, and what is happening here, on 23rd September as well as on the 21st March we are observing 21st March, equal day at zero equator, equal day, equal night, equal day, equal night, equal day, equal night, equal day, equal night, equal day, sorry, this portion is actually day, this portion night, okay, this equal day, equal night, equal day, equal night, equal day, equal night, equal day, equal night, equal day, equal night. Okay, so what we are observing, axis is becoming equal to line of illumination. Okay, number 2, sunlight is falling perpendicular to the equator. Number 3, days are becoming equal in everywhere. Okay, and similarly on 23rd September also sunlight is falling perpendicular to what, equator, and here also equal day, equal night, 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 same thing, equal day is becoming equal night. That's why 21st March and 23rd September is said to be what, equinox. These are said to be what, equinox. Okay, these days are said to be what, equinox, because days are becoming equal to what, night. Okay, everything is same here, all are what, same. Thus we can conclude that both this rotation and revolution are what responsible for formation of season.